All right. Atención, you ready? All right. So there's a little bit of pizza left, some salad. You can definitely open up. I might open it up to be loud now so people can grab it if you want. Sorry if I undershot and people don't get pizza. I tried. Welcome to the group. My name is Dustin Vandelay. If you don't know me yet, great to meet you. Great to see you. Got a good turnout tonight. I think most months it's just a little bit more than this, but it's December. I'm busy. I'm tired, so I figure other people are too. But I'm glad to be here with y'all. Ike is the other leader of data engineering San Diego, so I will let him say what he wants to say once he's done playing with Zoom.
You see the problem with Zoom's in the way. Okay, there we go. All right, fixed. Yeah, my name is Ike Ellis. I'm the speaker tonight. So usually I'm hosting with Dustin, but you're stuck with me tonight. So I think a lot of you know me, a lot of familiar faces, but I lead a data engineering and data science team. And I actually have two different roles. I'm with a startup, and I'm also a consultant, and I have a consulting team that I lead. We do Databricks consulting and a little bit of Fabric and Power BI. Yep.
And I used to consult with Ike and other people, if you're in the room, or one of them in the room. I work for Databricks now, in case you're wondering why you pointed at me and said Databricks. One other thing, maybe? Yeah, how about this? So we have a Slack channel that it's not super busy, but we do post about this there. You can also post on the meetup group if you want to. But if you're looking for work, my recommendation is talk to people around you and build some connections that way, because it's kind of an interesting time. If anyone's got a San Diego company hiring, or a company that's like hiring in the data engineering, ML, data space, anyone want to call out hey, go apply to my company? Well, give you 2 minutes here. Yes, sir.
I don't have a local company. I'm verification. I'm on the as a contract where I run the Databricks AI environment for Homeland Security and city. So we're always looking for data engineers, data scientists. The only requirement that we have is U.S. citizenship. So we have to be in the pipeline.
Okay. Sharon, anyone else? All right. I would keep an eye on ServiceNow. I don't know where they're at right now, but I know ServiceNow has been that's continued to have different types of rules open. So, and they have great facilities. Once you get past security, great place to hang out at. That's as much as I can say. I've never made it past the first floor, but cool. All right, I'll turn it over to you, and Benjamin's helping out too, so you guys can do it.
Benjamin take over. Yeah, so Benjamin and I did an interesting project starting in June and going on through November, where we kind of modernized an ML implementation that was not done optimally. And what we did was we took what existed and we migrated an awful lot of it over to Databricks. And as we did it, there were a lot of things that we wish there were documentation on, or maybe better guidance on, that we really struggled with. And so after a lot of trial and error, Benjamin and I wrote it all down and said, this is what we wish we knew, right? And so that's what we're presenting to you, what we wish we knew when we started the project in June. Does that sound right? And then we're going to show you some code. So I'm going to talk and do the basic presentation and show you the big strokes of what we learned. And then he's going to show you the actual code and walk you through actual implementation. Does that sound good? All right. So do they go? You're not going to go? There we go. Okay. So my part will be showing you the overall ML strategy. You know, we're not a traditional data lakehouse. In fact, we don't keep any state in our Databricks implementation. So we didn't ingest a bunch of data. We don't run it through ML models, and we don't save the result. We don't do that. We know how to do that. But for our implementation, we were stateless. We were taking requests from an application. That application had a lot of AI and ML needs in it. And then that application would give us all of the state in parameters. We would do our work, and then we would hand back the result through some mechanism that I'll get to in just a second. And then we'll show you the overall architecture and the advantages of Databricks. And then we'll also walk through and demo MLFlow models, inference endpoints, Langchain, and we'll show you the benefits and pain points of each implementation. And then we'll talk a little bit about the future that Databricks actually just announced yesterday. I don't know if you've been keeping track of what Databricks released yesterday, but they released a whole bunch of new features yesterday in public preview, I should say. Some of them aren't GA yet, but you can go play around with it today or tomorrow, whenever you want, right now. So when Benjamin and I inherited the application, it was just a bunch of Docker containers. And there were Docker containers for the front-end app, and there were Docker containers for the back-end app, which was like GraphQL and some APIs, like Fast API. And then there were Docker containers for Neo4j, which was the data store. It was a graph database implementation. And at first, the Docker container that had all the ML models was the same Docker container that also had the Fast API server that was serving up Python REST endpoints. And you can imagine, they stuffed every single ML model in one container with their API layer for the machine learning. And it was, you could imagine, it was running out of memory. It was clashing all the time because we had global address space conflicts all the time. Updating it was a big pain. A lot of different problems, right? And then we had a bunch of other containers, so all in Docker. We also had a problem where, in order for a new developer to use machine learning, they would have to download this giant Docker container that had a lot of memory requirements, and it didn't work for them because they didn't have 96 gigs of RAM or a good enough processor or anything that could actually run these things, right? So we had a big problem with developers trying to code locally, and then they would crash all the time. So it was fragile, right, Benjamin? You would say that was fragile? Yeah. Okay. Yeah, Kubernetes, yeah, Kubernetes, yeah. Okay, so just real quick, before we go any further, we wanted to introduce Langchain, if you've never heard of Langchain before. So who here has heard of Langchain? Here. Okay, that's pretty good. That's almost half the room. Okay, good. So for those of you who haven't heard of it, the last 12 months have been all about Gen AI and OpenAI and ChatGPT. And we know that there's like an arms race for large language models servicing the customers. And this arms race is primarily between Microsoft and OpenAI on one side, and maybe obviously Google. And you might have heard that Google had a huge Gemini release yesterday, which was made for papers, and everybody's playing around with it. And then Meta and a little bit of AWS, not too much. And then, of course, Musk seems to think that Twitter's got something, but nobody's ever seen it yet. So there's a lot of news dropping about LLMs all the time. And if you write directly to the OpenAI API in your applications, then if you want to change away from OpenAI, you have to rewrite all your API calls. So any smart developer would use an adapter pattern for that. And you would say, okay, let's just generify this a little bit so that if I ever want to replace OpenAI with Bard or some Google implementation or Llama 2 or whatever, I can just replace the engine and not have to replace all of my prompt engineering and everything that might go into calling an LLM, all that stuff, right? Well, Langchain did that for you. So Langchain just basically created the adapters for you for that exact purpose, only they carried that adapter pattern probably further than you would be inclined to carry. So I don't know if you are keeping track of any type of, RAG or different machine learning models in production, but basically there are vector data stores that people want to use. There are different ways of handling prompt engineering. There's embeddings. There's a lot of different components of a good LLM platform, and I'll show a slide about this at the end of the presentation. Well, Langchain uses the adapter pattern for all of those components. So if you don't like your vector store, you could swap it out with Langchain. If you don't like your embeddings, you could swap it out with Langchain and not have to rewrite everything and redo the entire platform. So anyway, the Langchain has an MLFlow integration. MLFlow is a Databricks product that helps us do things like model registry and swapping out models and versioning them and iterating them and testing them, things like that. So we've got a slide for that in just a second. So all that to say that this summer, what Benjamin and I did was we implemented Databricks. And we took a lot of the machine learning models that were in that Docker container, right? And we threw it into MLFlow. And we registered these models in MLFlow, and we created what's called a model serving endpoint, which is an inference endpoint where the machine learning models are hosted in a REST API. And the app, this is all the Docker container, this is all the apps. The app can just make a REST call and say, hey, here's some data model. Can you please give me the result I want? So some of the things that these machine learning models do would be like, hey, here's a bunch of text. Can you tell me what software they're using? Or here's a bunch of text. Can you give me sentiment analysis and tell me if they're angry or upset or happy or they like the process or whatever, right? Or here's a bunch of people who've responded on this survey. Can you group them together in a certain way, right? So those are all things that our ML models are doing, and the app makes the REST call, asks for whatever it wants to do, and then you respond, and it goes back to the user, right? All stateless. So this was, oh, by the way, one more thing. Langchain for GenAI stayed in the Docker container. So we kept that there. We didn't see a lot of benefit in moving that over to Databricks. So we still, because really it would be one more hop. Right? We didn't want one more hop, right? So we just wanted the app to call OpenAI, the OpenAI API, and do all the GenAI work outside of Databricks. That's where we stood this summer. So there's a lot of Python and stuff in there where we're doing data prep, data cleaning, data organization, and then of course all the GenAI and LLM calls. Okay. So what are the advantages? Well, getting all of those models into Databricks really made it very easy for us to implement new models or swap models out. In fact, you can change the model in Databricks completely. You can say, instead of Roberta, we'll use Spacey, or we download something from Hugging Face and we just throw it into MLFlow in Databricks. And why was that beneficial? Well, we don't have to change the REST call. So the front-end app doesn't need to know what the data scientists are doing. So the data scientists can swap all the models in and out, or version them, or upgrade them, or do whatever they want to do with them. And the app doesn't need to know. Meaning we don't need to go through the app's deployment pipeline in order to take advantage of that. And that was a huge, huge benefit. And then developers had local development environments, but they didn't need that huge Docker container for ML work anymore. They just called our inference endpoints, right? That's all they had to do. So now they were irritated they couldn't work on the train anymore, right? They couldn't work in an airplane. Well, they could work. We had a way for them to work, but we didn't really implement it yet. But we had a strategy to let them work offline if they wanted to code offline. Another thing it did was it documented the use of our ML models. So we could change our strategy, and we could see the version history of what we did over time and the results over time. So we could, maybe not everything we ever did was a good idea. So we could change strategy and then compare results and say, was this giving us better results or worse results? And then we had a rollback path that was easy for us to implement and understand. We isolated dependencies in the global address space. So earlier when I told you that we were colliding a lot in that Docker container, by isolating ML models in Databricks, they could all do their own work without interfering with each other, which was really helpful. And then the last thing is it increased ML experimentation. Now let me just show you that. So one of the benefits of Databricks, real quick, is that it's really easy to see each other's work, and it's really easy to work with each other. So you'll see that Benjamin has a folder here. So, okay, you know what? I thought that would do automatically. Let me close it. Okay. All right, now let's do this. There we go. Okay. So you can see that I'm in my source control repository, and everybody on the team has their own local Git repository. Well, kind of local. It feels local, like local Git, but it's actually in Databricks, which is a PaaS service, right? But I've got my place to work, and Benjamin has his place to work. Now, if Benjamin was working on something, let's say that he was working on one of our models, like he was working on Spacey. This is a very interactive way of working with each other. So if Benjamin started coding, I could see him coding in real time, and he can see me coding in real time. And that is a phenomenal feature for data scientists, many of whom are very used to working in silos. They're really used to only doing their work in an IDE. Some of them don't even like using the same IDE. Like one data scientist says, I only work in VS Code, while somebody else works in PyCharm, and somebody else does whatever they do, and they don't really collaborate well together. But having the entire team use Databricks, and you get notebooks, and you get access to all the local data, not only can we collaborate in real time, but if Benjamin says, I've got that on my branch checked out in my repo, just go look at the code. If he's doing something I want to bring into my code, it's super easy for me to go first examine what he's doing and then decide if I want to, merge his branch into mine, and then before I do all that work, right? And I'd say, oh yeah, I really like what he's doing. Let's collaborate and get that done. So what that did by moving to Databricks is I really feel like it improved our velocity as a team. Like we were collaborating more, we were writing a lot more, we were doing a lot more, and we were moving really fast. So I really like that part. Now, there's some disadvantages to this. We had a bunch of REST API calls, which are not great for a lot of models. A lot of machine learning models need time to do their work, and REST probably isn't a great solution for that. The data preparation Python code was still in the Docker container, and we wrestled with cold starts for quite a while, and I'll get to the cold start problem in just a second. So what's in progress right now is we are using Kafka to make requests and Spark structured streaming jobs for some of our work. And this is obviously an asynchronous pattern, which means that the application dumps some data onto a Kafka topic, and then our Spark structured streaming job picks up that data off the Kafka topic and either calls an inference endpoint, a model serving endpoint, or uses MLFlow directly through an MLFlow UDF. And there are different use cases on why you want to do that one way or another, and I'll explain that in just like 5 more slides. But bear with me, and I'll get to why
Kafka or another thing. It doesn't seem that it's a high request API. We get like a US, a little less complex.
No, we pretty much just use Kafka, and we just like Confluent, and our load will get more sophisticated. So we have HP selling this product into 10% of their enterprise customers. So we needed something that we could scale quick. Okay, so you could see that through this method, in the Databricks jobs, we put a lot of our data prep and work in that job. So a lot more of our Python that was in the Docker container started coming more and more into Databricks. And you can see by the diagram that Databricks' footprint became more and more, and the machine learning work that was being done in the Docker containers shrunk. And with the announcements of the last couple of days, it looks like it's going to shrink even more.
Question.
Yeah.
The team that manages the backend and that's with the Databricks are those different teams with different
and that's another big reason why we elected to go this direction, is we didn't want the data science team to be beholden to the cadence of the rest of the application developers. So the other software engineers are releasing it whatever they release, right? Well, we want to iterate on our own schedule. So Databricks allows us to do that. Okay. So what are the advantages? Well, this is good for all calls from the back end. We have now options for handling the cold start problem that are a little more affordable. We can deploy using Databricks asset bundles. And if you're interested in asset bundles, Dustin has a phenomenal video on YouTube talking to you about your deployment patterns on asset bundles. So check out Dustin's YouTube channel. He did a great job explaining it. In fact, we used it to learn about it as we implemented it. And then now we know we can scale no matter which models we use, how much data we use, how many users, how many requests. We have a very easy to understand scaling pattern. Add more nodes to the Databricks cluster, add more partitions to the Kafka topics. Beef up the inference endpoints. We know that we can scale. And it doesn't matter how many users or how much data we have. Now, disadvantages, we were having a latency issue for a while, but I think we might have solved. And Kafka complicated our CI/CD process and our deployment process a little bit more than we would have liked. But overall, we're pretty happy with the direction we're going. Okay. So I wanted to talk a little bit more about MLflow and what it is. Again, this session isn't meant to teach you about MLflow, but we can, you know what, actually, yeah, I do. Yeah, I do, because what I want you to do is show it. Okay, do you want to show it now?
Yeah.
Okay, Benjamin, take this. Do you want me to get off this slide and I'll?
Well, let's leave the slide up in this view, and then I can,
Okay, sounds good.
How do I make sure I go back to?
While they transition, I'm going to call out that MLflow is open source, even though it was created by the team at Databricks. You'll see it outside of Databricks and other things, including some of the Azure tooling. So,
Well, yeah. So Databricks is effectively the standard ecosystem around open source products. So the reason why I mention that is Spark, which is Databricks' main moneymaker, is open source also. So I didn't mention that because I guess I just figured it implied. What Databricks' standard operating procedure is to release, a major portion of their products open source. And then if you want some cool bells and whistles for integrations or connectors or some other cool things that it does, then you have to pay for it. So we can use Spark in a lot of different ways. In fact, you can install Spark and list it yourself if you want, but it's very, very painful in my opinion. So Databricks is much more seamless and then easy to implement. And so MLflow, like he said, is open source, so you can implement yourself, but just pay Databricks. It's a lot easier and it saves you a lot of time.
But I mostly call it out. So if you're in this space and you don't think you're ever going to Databricks, but you do have the option to work with MLflow, this is still really useful to go. It's very useful. So
Yeah.
The
The managed system is really nice, right? Because it has to run, I think, some MySQL database in the background, right? Because as we'll show here in a second, you'll see that there's a lot of meta information that's involved with that. And then there's also some deployment stuff that if you look down the path of hosting yourself, it might be useful to check out. But I really think, as it was said there, the managed services that Databricks provide is just, it's hard to compare out of the box open source to, they not only provide it to you managed, but they usually add on nice features, whether that be UI features, UI UX features, quality of life features, or optimizing features. Yeah, I can't speak highly enough about it. But on that same note too, right? With the ML experience, whenever you use a service like Databricks, in case you have, has anybody else? I mean, obviously you've been working on with ML in Databricks, but does anybody else work on a cloud platform, maybe Fabric for their ML work, or SageMaker in some sort of collaborative environment?
You should see it.
Yeah.
And we use that also. Just a couple of things. You've been doing it for a long time. So the price point to learn Databricks on those things so low that you can get an account, you can spend $50 a month to learn Databricks. It's really cool.
Well, I really wanted to emphasize the collaborative nature that he had brought up, which is just like having compute that's built on a platform for that eliminates a whole level, like it abstracts away a whole pain point. I don't have to get TensorFlow working on my machine to try out my, colleague's new model. I don't have to download those artifacts, which is where this wraps back into this.
Yes. Right.
Is that, we talk about isolated dependencies, right? That is a huge portion of that, right? We have this Docker container, that Python, we had a fast API Docker container, right? And we're pulling in all of these different models with all these pure dependencies. Well, whenever you're able to isolate them in environments like that, or even like download them, which you'll see here in a second, around downloading them in a notebook scope inside of a Databricks environment, it makes it a lot easier to move quickly, try new things. Maybe I'll come back to this slide, but let me just kind of show you what kind of a little bit of a template we were working with, where essentially.
Yeah, that's good.
Everybody good? Also, AI system's pretty cool if you guys haven't tried it.
Yeah.
Always like that too. So essentially the kind of workflow here that, we set up as a team was like, hey, we want something that like a notebook that we could automate that would create, test, and add this model into a repository. There are ways to take it all the way to sending it to a serving endpoint. And you can add complexity on complexity on complexity, however you want on top of that, right? Because within Databricks notebooks, you can have, what are they? The variables that you can inject through jobs. What's that? Widgets.
Yeah.
Yep. You could add widgets and you could get really technical. I don't know if that would be the best way to automate different model variations, but it's possible. But as you can see here, like we're saying Spacey 4.4, we're installing it locally, right? Or locally as in like in the notebook scope. It's not like based off of the cluster. So that means that someone else can, train. We actually had multiple models using different versions of the Spacey, for example, as a backbone to their necessary business function or feature. So as we go down a bit more, I might have to put that one more. Is that still good?
Yeah.
Okay, even everyone in the back? Okay. Yeah, you got the restart Python there. Here's where we want to download essentially the English library for this example, which again, like there's small, medium, large. Now we have the ability to swap those out. But the whole idea here is that I want to take all of my core features to this model and get them into that cluster environment, because whenever we're bringing that into MLFlow, we want to take those artifacts and like freeze them, put them into the model in the repository. So it's not something that whenever you pull the model, they're re-downloading these artifacts. Again, going back into that old developer flow, we had to write a shell script that included with the build for that, where it literally had to like SSH call, get like it was a lot. And you're downloading these, 8 gigabyte to 3-4 gigabyte models, and the consistency with that whenever they're doing development, let alone again, if their computer could handle all of that in Docker. So as you can see here, that's where, again, I'm taking this, I'm making sure that I'm loading it up into Spacey manually, and I'm adding that, and I have to, force it to disk. Because again, I want to take that language model, put it on disk. It's ephemeral, right? It's going to go away after the cluster gets shut down. Check to make sure that the artifacts exist. So the pattern I found to be useful is just like create a temp folder, dump all the artifacts there, and then whenever you actually go to log your model, you want to pull those artifacts and log them in your model. So again, with I found this very useful. The PyFunc is kind of like a high level of abstraction for MLFlow that you can kind of, as it says, Python model. You only really have to implement 2 functions on this class. So you only have to implement a load context and predict, and that's it. And it can.
This is already trained machine learning model, right? So either we trained it or somebody else trained it. In this case, somebody else trained it, and now it's functioning. It's doing its job. It's been tested. We know how it works. Well, with the machine learning model, what you're doing is saying, here are your inputs, right? Here's the data I want you to operate on. So let's say that this machine learning model's job is to say, what software is being mentioned in this comment, right? Tell me if they're using Word or they're using Gmail. Tell me any software product. So we give them the model, the input, and say, here's the text we want, and the predict responds and says, here's the software that existed in the text. Right?
Yep. So again, I guess I don't need to walk through the full implementation of a PyFunc model, but it's fairly easy to follow if you've written enough Python code. And I just want to, you could put anything in there. So this is an interesting point of as you saw the data cleaning step, you could put that logic in your inference endpoint. You can have it outside. It's your model input here is important because that level of abstraction whenever you're designing these are important because you can implement your model through even delta live tables, I believe. You can load the models and do predictions on columns. You can do it as a batch on streaming data frames or on large data sets. You can do it, again, like this, hosted as a REST API. So really think about like that level of abstraction if you're looking down this route, because you want to use the correct for your application. So let me go through this. Oh, go ahead.
This piece here, that's going to make a prediction call to a model that's in the registry, right?
Well,
do you have to have a special serving endpoint up for this to work, or does setting this up take care of that for you?
No, so
well, this is registering the predict with the MLFlow machine learning model.
Okay.
So you'll see it in the UI. It's probably easier to show in the UI.
We'll get to it, but I think even to clarify, this is the development flow. This is a developer going in there. Let's say we want to update this model, and that's what I'm walking through here. Is a developer is going to go in there. They're going to change that piece. This is how you need to create this model, this PyFunk model, in this workspace first before you can log it. So if I scroll down just a little bit more, you'll see I get test data. I have a little utility class. I wrap that as a dictionary here. And basically what we're doing is we're instantiating that model in memory and testing to make sure it works, right? We want to make sure that it loads the context. So that's actually what's happening under the surface. It loads the context, does the lazy imports, pulls in your artifacts, uses those artifacts to create that class, and then you actually use that class to call up predict manually, because this is, again, the developer flow. We want to make sure that we use the same inputs and it doesn't fail. We have business requirements. If it does fail, you could add all sorts of testing in here, raise exceptions, etc. But we just kind of just do a print, just keep it easy. This is the actual step where we're taking that and we're saying, okay, it passed that cell, it compiled essentially, right? It built that class. We were able to test it. Now let's create a run and log the model. So essentially within MLFlow, you can, again, this is where I think that in any sort of, if you're seriously taking this route, like spend some time to think about how you can log parameters, log metrics, things that you want to be able to compare between models. You can put whatever you want in there. One other thing I can mention is that certain models, especially in the Databricks environment, in an ML cluster, will auto log, which you might want to turn off in a testing environment. AKA, if you're using why am I blanking? What's a numeric ML model? It's like the most popular. What? Like an actual ML, the next level up. NumPy is just like a tool that I mean, NumPy to me is like pandas. There's a bunch of auto logging features. I could show you exactly what I mean, but essentially for certain models, if you instantiate the model in a Databricks environment that's ML, it will automatically log the model. And whenever you're going through this, I don't have a cluster running right now, but whenever you run that, you would see that this screen would populate right here, where we can actually see my previous runs of this model, aka these logging statements, and I can see that, hey, this is my model that I've upgraded to a published model. These are experiments. This right here is an experiment, right? We have our artifacts, we have our requirements, we have our signature, which is your input-output schema, and then we have, just some naming, and then you have your actual model itself. Down here, I found it really useful to then take that model from the experiments, retest it, make sure that the artifacts were loading correctly from the repository that MLFlow provides. And then lastly, we want to actually transition the stage of that model, which is the difference between these two, where you can see that this is in staging or production. I can't tell from this screen. This is just an experiment. So I think that, Ike, you were saying to go over to models,
yeah.
And let's talk a bit about, right at the end of this, we were saying like, hey, we could automate setting this as an inference endpoint, but we don't need to do that. We can just manually set these up. So as you can see here, we have several versions of Roberta here. But let's go back to that extractive summaries. We could see here that,
That's not a good one.
is it? So we can see all these different versions where you can archive them. You can see the different versions, you can roll them back. And if I click on version 8, you could see the source run. You can go back in time with that. You could see, this is that schema piece that I was talking about, the input output schema. So I can see that it needs to have an index, a column name, and text, and it's going to output an index, a sentiment label, a column name, and sentiments. Because essentially, right, like I think this one was like taking a sentence and as many sentences as you wanted to give it. It could be one, it could be many, but then you're also like, or this isn't one that breaks it up, but there were ones where one row could become many rows. That's what I wanted to point out. This one is a one-to-one where you're always going to have a positive, negative, or neutral. I think it's kind of like the 3 sentiments. And as you can see here, the quality of life here is that we can track each other as we're doing work, and we can kind of, I just didn't find that whenever you track these through Git to be sufficient for long-term transparency and to be able to understand the thinking behind your previous team or previous team members. Models change all the time, experiments work and they don't work. But lastly,
Did you show going back to the original? Sometimes we lost some of them when we renamed the notes.
Yeah, we had that note there. I think there's ways to get around that, but as you can see, source run, we could see that here's the notebook, and then we actually have the Git hash here. So I wonder if this will open up. Oh yeah, the repositories. I guess we're not logged in there, but I think this might bring it back to the edit state.
Yeah, there we go. Oh yeah. So we renamed a bunch of our notebooks and we messed things up. But that typically takes you back to the notebook that you use to develop.
Yeah, and then the last piece that you'll see on this registered model, again, you have experiments, you have registered models, right? The experiments are more ephemeral. Registered models are like, hey, we're really checking this in. We want to use it for something. So how do we use it? Big blue button, classic. Here you can see we have real-time inference, streaming, Delta Live tables.
It's really important to understand that at this point, you're spending money. So all the other things, you're not really spending money. You can code in notebooks, you can experiment, you're just using cluster time as the cluster is up. But the cluster, like we used the heck out of it, and we would spend $100 a month or $200 a month. But the minute you bring one of these online, now there's real money involved.
Yeah.
Does Databricks come up with a cost-effective solution for inference, certainly on GPU inference, where you're paying like?
I'm gonna.
Yeah, you gonna talk to them. Okay.
Well, I think
to that. We're gonna wait.
I'm not gonna talk to what Databricks is gonna do. This isn't my specialty area anyway, so I'm definitely not gonna talk to them.
I think this is really funny that came out, but I think that your next slides kind of speak to different approaches for different business cases and why you might use something.
The next slide.
Yeah, but I wanted to point out that this is what our probably hardest to run model. It's named entity recognition. And I just found this to be hilarious that I think that they're still here. Yeah. So now, and this was something that literally 2.5 months ago was not a thing. You can select GPU. Look at that. The A10Gs. Look at the G. Look at right now. Zero cold start 64. That's not super expensive, but you'd be a better guesstimate. That's not crazy. It's not crazy. Boom.
Yeah.
Oh yeah.
Let's go.
$30,000 a month. Wow.
Yeah, so if you're using those, and I really think that all of these 3 are really just dedicated for LLM related, dedicated your own hosting your own LLM and getting inferences out of it. There's really,
which for the record, I mean, this isn't a topic of this talk, but I do not recommend hosting your own LLM at this point. I do not think that is worth your time or your money. In my opinion, you know, and you can hear Sam Altman and other experts talk about this, but LLMs are basically a commodity. Like it would be like hosting your own electrical grid because you needed power. And whatever you host, like in Llama 2, it won't be as effective as OpenAI or Bard will be. And they are in a price war with each other. So if you paid attention to the dev conference for OpenAI a month ago, Altman was on stage and said that they slashed their prices by about 3 times because they understand they're getting increased competition and they're trying to lock the market up. I don't think you're going to be able to run your own LLM on any platform more affordably than just making the GPT calls.
Yeah, there's a couple of caveats on that, right? You don't want your data, because we were one of the first to implement Dolly, where we self-host Dolly, we self-host Bloom, and we're self-hosting Llama 2, right? Because we don't want the data to go outside of the boundary, right?
Well, okay, hang on a second. I've got a counterpoint to that. Okay, so if you use Azure Government, you can use OpenAI in Azure Government, and it stays inside Azure Government, and that's CGIS compliant. I mean, they're able to use that and store, you know, federal criminal prosecution data in it.
No problem if you can get your security officer to approve it.
Yeah, that's right.
Okay.
Well,
yeah.
let me finish this before I pass the mic back over. Yeah. I wanted to make I'm glad that it actually, again, the UI and the progress that they're making in this space at Databricks and is happening quickly. This workspace is Unity enabled. We did do some ingestion. We did want to use our own models, never came to fruition. I moved on and things happen. I just wanted to mention around this inference tables. So I believe this is only for Unity catalog enabled spaces right now, to my knowledge. But essentially what this allows you to do is just set up a Delta table for all your requests, all your predictions, dump it in there. You're good to go, right? If you want to retrain your model off of what's doing in real time. And if I tie this all together, whether you're doing data engineering, machine learning, and analytics, or all three, I just can't stress that, like, these kind of solutions make it so that we can focus more on our domain and collaborate, or not, as a business, not even need large DevOps teams. Again, to achieve something like that, where you have a registered model, you have the ability to train the models, you have the ability to serve them, you have the ability to log all of this, like, as tables, inputs and outputs. You don't need to spin up backend services. You don't need to spin up databases. Like, you can kind of just, sure, you're going to pay, you might be paying a little bit out of your pocket for some of these services, but I don't think I've seen a situation where that's more expensive than hiring the engineering talent you need to do it right. So I hope that gave some context.
Thanks. Okay, so to wrap up quickly, we didn't want to take up too much of your time today. Okay, so this, if you're awake still, this is kind of the heart of the presentation. So if you're doing these example use cases, for instance, your ad serving, which means you have some e-commerce site or some site, and you want to make a recommendation of another product to buy, or you have another ad that you want to serve, and you want to do that based on the user's behavior, that is time sensitive. So you need to be able to react to that immediately. So if you're going to use Databricks to do this, we would say that you wanted a synchronous call, that you needed to be low latency, and that this was going to be expensive. And the reason why is because you would use a Databricks model serving endpoint that you kept hot all the time. So like our friend, what was your first name again?
Eric.
Eric, like Eric mentioned, he just asked, when are they going to make this affordable? Yeah, it can be expensive. So, but it's worth it to keep it hot all the time if you're doing fraud detection, right? You don't want to wait to know you've got a fraudulent transaction coming through. You need to catch it right then, right? So that's when these are the use cases that justify that expense. You saw Benjamin choose the size of the model serving endpoint, whether he was using GPUs or CPUs or the size. That's how you control your costs. So it's critically important that you understand your load and how quick you need to respond in order to determine those sizings. But let's say that you're a little bit more tolerant of latency, but you still want a synchronous call. A really good example of this is a chatbot, and everybody's writing Gen AI chatbots right now. They're all in every single app I ever look at, and people, oh, look at our new chatbot. Hey, we got a new chatbot. They're everywhere, right? Well, if you remember, in most chatbots, you say, hey, I want to talk to somebody, and there's like a wait, like maybe you wait a minute or so, and then boom, hey, I'm online. You think you're talking to a human, and you're really talking to some GPT somewhere or something else. So if you're making chatbots, you can still use a model serving endpoint, but you can keep it cold. Now, if you keep it cold, there's a spin up time of a minute or two. And then it spins up, and then it's hot. And then every other subsequent interaction is in real time, right? But then if nobody's using the chatbot, that inference endpoint, it times out, it all winds down, and you don't have to pay for it anymore. And so that means that you can play around with the sizing a little bit. Maybe in heavy periods of the day for your site, you can make it a larger endpoint. And maybe at night, you just make it smaller and spin it all the way down. You can play with that to save money. So yeah, if you're doing form processing or you're analyzing data from documents or like survey results like we kept it cold. So we call that implementation the serverless implementation. So if the first one I showed you is real time, the second is more serverless because we're more latency tolerant. That make sense? Okay.
Oh.
Yep.
I wanted to mention, because it's also changing, but one thing to note is that there's maximum run times, which has increased,
yes.
right? I think whenever we first started, even 5 months ago,
but it's about a minute.
It was like 90 seconds, and now it's 120, as well as maximum model memory size, which I think is around 5 gigabytes
4
right
gigs.
now, 4 or 5, yeah. But that's important to note because the next two, like you have to understand that those last ones, if your inferences can't be made under a minute.
That's right.
Yeah.
Yep. You want to be, obviously, if they're async, obviously, if they're synchronous, you want to be quick, right? Make the call, get the response, and you want it to be relatively simple. Yeah.
What about security DDoS attacks? Is managed by Databricks?
Like denial of service attacks? Yeah, it's managed by Databricks. Yeah, managed by whatever cloud platform you're on too, because keep in mind, these are all just Azure clusters underneath, or AWS. We're using AWS for this implementation. So
if you run it in a private network, they're not exposed. So
yeah,
AWS is not really going to happen. If you're that deep into the AWS network, DDS this thing, you're in real trouble.
Yeah. But the cloud platform providers are doing that type of network security for you. Okay, that's true. So, one other thing is, in real time and in serverless, we're not really using Spark here. So we're using Databricks, but not Spark. We're just using these MLFlow model serving endpoints for inference. That's it, right? This next type, asynchronous, we are using Spark. This is the first time we're using Spark. So the application makes a Kafka request, dumps a bunch of data on Kafka. Databricks streaming job picks it up, calls an MLFlow UDF, and then returns the response on the response topic for this implementation. This is good when your processing time is between 1 and 60 minutes. So we expect that in asynchronous calls that the application lets the user go do something else, right? Like this is going to take a minute. We'll let you know when this work is done, and then we'll tell you the work is done. You can go look at it, right? So we just kind of do some type of whatever syntactic thing that we need to do to let the user know we're going to work for a long time here. We control cost with the number of Kafka partitions and the size of the database job cluster. So those are the expensive things. Notice there's no model serving endpoint here, so we're not controlling cost the same way we were before. And this is really good if we're doing like image synthesis, like tell me what this thing is, or known entity extraction, like Benjamin said earlier, sentiment analysis, anomaly detection with time series data, like we're in a big IoT environment, and all of a sudden we notice some weird, pattern in the data that we want to go back and tell users, hey, go check something's weird here, right? That can all be done over Kafka. But as soon as the processing time is over 60 minutes, this probably isn't a good implementation. Instead, what you would do is batch inference. And what we would do there is we would have a data source like a file or a database, and we would schedule at some interval a Databricks job to go get the data, call the MLFlow UDF, and write it out somewhere so somebody can check it later. And this is obviously for very large amounts of work that we're going to schedule to run at night, or we're going to schedule to run on every hour or something like that, right? And we would do this for like different types of propensity modeling, predictive maintenance, churn prediction, and other type of things where we're operating over a large amount of data, and it's going to take us a while to get the results back. So you only pay for the duration of the job. So how long this thing runs and how large the cluster it's on, that's going to control your cost. And it's suitable with your processing time. Is it measured in hours or even days? I don't think in Databricks there are too many jobs that are measured in days, but you get the idea that this is for big work, right?
Are you going to mention about the delta table? Because I can speak to that.
Sure. What do you want to say?
I think he had it on the first slide, but I think it's in public preview now. But essentially, whenever you can now set it up so that basically you don't even need the job. You can have the model inference, do it on all updated inserts or upserts on the tables. And I think that has some very useful use cases in the future. I hope I have a chance to implement that somewhere, because I find it to be, just again, like as long as I can have it somewhere as some of that infrastructure as code, that'd be great. But I think that there's some really interesting use cases.
Where do you set that in the model registry?
Can you go back to the first slide? Can you just go back to
Hold it out
I forget the name of it. You had it on the first, like the slide after. No, like I mean the first slide of the whole presentation.
The first slide. What did I say?
Next slide. One more. There we go. The AI gateway.
Oh, there we go.
Branding. That's the branding. It's the AI gateway. And the example that you linked that back in there, I'm glad that you looked at, is vector databases, right? Like you'd have a vector store, and then you can make inferences, or you can just insert and write. So technically, when tokenizing,
they released a blog post on this yesterday. So if you go to the Databricks blog and you want to learn more about what he's talking about, read the blog post that they released to public preview yesterday. Then they released one on their vector store today. And then they're going to release one on I think they changed the name of the AI gateway actually, but whatever their new name is that I can't remember, they're going to write that tomorrow. Okay, so this is, what's that?
I said, all right.
Yeah.
I got the one from yesterday open on my phone, but I haven't read it yet.
Oh, good. Okay. So this is the logo for Andreessen Horowitz, A16Z, right? They're one of the largest venture capital firms in the Valley, right? And a few months ago, they said, if you want to write an app stack to implement Gen AI and LLM work into your application, these are the components you need. And they kind of talked about all the different vendors and all the different components that needed to integrate in order to get this working on a platform that can make REST calls or async calls back to an application that might want to implement Gen AI. And this is nothing to do with our presentation today, except to say that we're doing some similar work, but this is our stack. And if you compare the complexity and the different products to do all the different components that Andreessen Horowitz thinks you need versus what we did, you'll just see Databricks everywhere. And now we might be paying a lot of money for that. And maybe there are better ways to do it. Maybe it's not best of breed, and maybe some of these features are not as mature as some of their competitive features. All of those things may be true, but for us, like Benjamin said, just having one vendor and having it all seamlessly work together was very productive for our team. So we might be able to ignore some of the other deficiencies in order to get the benefit of like, this stuff is all working together and we don't have to think about it too hard, right? So that's it. That's our presentation. This is Benjamin and I. Thank you very much for listening to us for an hour. We really appreciate it. And let us know if you have any questions. What, did I mess up something?
The startup came.
Oh, yeah.
I typically go startup jockey, but I'll get the king title whenever I get some of those lottery tickets cashed, right?
Yeah.
You're using Spark, right? What it does, like, it will quite clear, like, the picture
Yeah, Spark is either reading off of Kafka or it's pulling data from a data source and ingesting it so that we can clean it, prepare it, and then either download the MLFlow model so that we can call it, or call the inference endpoint, which in our implementation doesn't really do, but it could do. You could do that if you wanted to do it. Benjamin, did you?
I could speak a little bit more to this, in that like any MLFlow model that you have in your registry, any of them, you can literally set it as a UDF. So it's like if you're using Python to UDF, and then you get a UDF function, and then you can use that how you would use any other UDF function, right? You can, we would do like a with column, right? It'd be like prediction, or with column, table with column prediction, and then UDF, and then you pass in the columns for the inputs. So it's like if it needs more than one column for the inputs, call column 1, column 2. And then you would have afterwards the updated prediction.
Yeah. So my question was like, am I right that like you have one hosted models, like just one? You have Spark cluster, you're using UDF to distribute your plot, but eventually it came to just one model.
Well, we weren't going to talk about Pydantic. I don't know if that's his question. Is his question that is the job only calling one model?
Yeah.
No, again, with UDFs, I almost feel like maybe somebody else can back me up, but the UDFs are serialized, so they get sent out to all the workers, right? Like all the UDF functions are serializable, so
I know what UDF is, but like in the day that UDF should call something, right? And that something should be some kind of hosted model somewhere, right?
Well, in this example, if you had a large model, right, you would probably have to consider your cluster size, because again, whenever you instantiate that UDF, it's going to be that Python code that we had there. It's not going to use that hosted. It's going to use the Python code itself and rebuild it. Does that make sense? I hope we're getting closer to what you're asking.
We can discuss it offline.
We'll get some checkpoints later.
But the idea, I think the idea though is with a batch job where you're doing the processing the data as it comes in, whether that's a stream or well, especially if it's happening like hourly or daily with a large chunk of data, having this endpoint that you do these API calls over HTTP to is not
right
as ideal.
Because you want to operate over the data as a batch.
Check your node and having it in parallel.
Yeah, the reason why Benjamin said use the with column is because you want more of a set operation. Like, hey, here's a bunch of data we want you to be operating over all at once. You don't want to be calling a REST call for every single thing you need.
But the semi-official answer to in batch, do I use this that they showed with the UDF, or do I use an endpoint? Is, well, it depends. So, right, there's a lot of different reasons you might not do what I just said, but it would be for batch.
Completely different, right? That REST endpoint is going to chew up GPU because it's not super multi-threaded, right?
Well, it's, to my best knowledge, just like SageMaker is probably using like Kubernetes underneath the surface, and like as it says cold start, that's like 0. But whenever you start it, it can ramp. It has auto scaling, so right. It's definitely like
it's going to scale on cost, right? And if you put it in that UDF, the UDF just is like Spark magic. It takes this function that would take 3 minutes to run in a normal Python thing and runs it in a millisecond because it's blown it out to all the workers, right? Mm-hmm. So that's what we find out is like if you can do it in a UDF, right, then you're leveraging Spark magic and things really perform.
Yeah,
they should add that in the pitch on why to use the Spark magic.
Yeah,
it's hard to teach people how to use Spark magic. It's not.
He's had his question.
Sorry, can you give us a little more on how you guys if you ever did manage the model development lifecycle of the tool, and then when the application generates data, these Kafka topics, they're ingesting those data, and my problem is like had cutoff days, nights, how the models are trained.
We didn't train any models here. We wanted to, but we never actually got access to production data. Okay. So all of the things we were doing, the application needed specific features, and we were pulling models off that had already been trained that were doing things pretty similar to what we wanted.
Right.
And then we would test the hell out of it. And sometimes testing took a long time. And then we would, bring it in production so that the developers and everybody else could use it. Our intention was to begin training, and we had a bunch of documentation on what we would do, and we did it. But hopefully we'll be getting actual production data next month.
Well, and also,
we would get alpha test data, but it would come in so intermittently that it wasn't worth having rules.
there are several different ways to load a MLFlow model in as a UDF. There's several different ways you can reference that. And there would be a pattern where, let's say you have a job that spins up every single night. It's not always running, right? You just have a job that spins up every single night and grabs the latest model. That is something you can do, where you wouldn't have to update the job and you can continue to change out the model in the registry. Does that make sense?
Yeah, I mean, at a very high level, I just wanted to see if you guys were to take any approach to make this as a lifecycle development. Data comes in through the application. We'll have to make sure that there's a cutoff time that our data is ready for our ML scientists to train it on. And the model at that point gets version or control at any registry level, very high level. And the next batch of data or application is just like, there's a flow of data coming in all the time.
I don't think we were that mature in our thinking yet.
Okay.
So we didn't come up with the best practice for that.
Okay.
Yeah.
You typically write a notebook that checked all these things before you invoke.
Yeah.
So it's just, it's done, but it's not through kind of the
Well, I thought MLFlow would be something that, has some platform, has some foundation around it, just to take care of it.
It definitely does, and I definitely, if you haven't taken a dive into the documentation, it's pretty good. And I wish we had a little bit more trained models and stuff to kind of elaborate more on especially the UI that's provided on the ability of A/B. Like you can compare the two, and that goes back into the metrics, right? Like what you would want to do is in that notebook that you're training, it's like, what was that training data set? You could have start time, end time of that training data set, and you have resilience in that repository where you can, again, customize what you found to be important, like whether it's changing temperature, if we're looking at temperatures or different sample rates and et cetera, any of the dials that you want to add to your model as well as the source data sets. I really suggest checking that out because it does definitely cover that.
There was a yeah.
If we have time in a minute, are you able to pull up the model registry where you can find the model and move it to the stage of the dot just to show that?
Yeah, we can show that.
Maybe that's next.
Yeah.
Actually, my question is the same time. I wonder if A/B testing, let's say we figured out the A/B testing of one traffic code, this route and the other traffic code, that route, and we have two versions of MLFlow. Have you thought about ways to validate these elements before these model performance responsibility?
Yeah, that's part of the thing he was showing you about the table check is you can capture like this model was being used and these were the requests and these were the responses.
Can I talk about the computer real quick?
Yeah.
Something really quick.
Are you talking about ground truth testing? Yeah.
So
did you guys have ground truth on your spacing model? Like you had a set of data that you knew what the outcome is, and sounds like you did extensive testing.
Oh yeah, we had a whole PyTest suite that I actually translated into Databricks jobs and almost got it all organized with asset bundles. But that's how we did model drift. But again, we weren't retraining it. But that's where we were using Verify to just kind of get again a spot check with stakeholders, a product person, or whoever had the say of like, hey, these are good. But I kind of want to also point out that we can add multiple models here. So as you can see, workspace model registry. This is insane, but I'm gonna click confirm because it's not going to deploy. This is where I'm actually taking two different models, serving it on the same endpoint, right? And I'm saying at this endpoint, I actually want these both to scale to 0, And let's say I want 50% traffic go to A, 50% traffic go to B. Boom. That's all you have to do for this. Again, it's like out of the box A, B, or if you wanted to like create a naming structure where you could deploy it, like you could create tags, I believe, that you could make it so it's more automated. Like, hey, I always want this version, or if you want to have different. I was thinking actually, no, you can't really have what's it called, multi-regional stuff here, because I know that's another use case for having many different models, like variations of models. Like I want my Australia model to run here, or if you're looking at the 50 states, you have different models for each state. But I hope that also shows that like within this in this ecosystem, right, and even the model serving endpoints, if you look at the MLflow documents, like there's actually even like Docker. You can take an MLflow registry. You can download these models on your computer as long as you have credentials to the workspace. You can download the models. You can run them as UDFs on your local machine. You can build them as Docker containers that are served endpoints. Like MLflow does provide a lot of resources to do a lot of different things within that space. But I thought this was worth sharing, and I'd be really curious on that output of like within that enable inference tables, like how it's actually logged.
I think we wanted to do this presentation in a month of announcements today. Because guess what? They had it on private preview. They announced a lot of these features we're showing you at the Data and AI conference last June. So Databricks has that big conference every June, and it's pretty awesome. And we spent months trying to get on the private preview. And we finally got approved for the private preview and went to public preview. So there's a lot of cool things that we haven't tried out. Like their vector search, they made YouTube videos that they dropped today on their vector index search. That's pretty cool.
That's so cool. They added in, this is a terrible example. I'm sorry to just like interject there, but like now you can take, I guess Databricks provided a nice UI to do more comparisons between your models depending on what you're logging as metrics. So that's pretty cool, like to visualize quickly like different metrics that you're logging based off of each model. Again, quality of life, I guess.
Yeah, it's definitely a place where it's like competing pretty heavily. So they're releasing a lot.
All right, you guys, thanks so much for coming, and thank you.
Cool. Thanks, everyone. Appreciate you being here. Feel free to hang out just a little bit longer and we'll start to